have a couple of videos. One that shows adaptation of a GRD. I saw a bit of interest in the idea that you can take a regular conventional hydromechanical grease interceptor and convert it to a GRD without taking the grease interceptor out, which is always a handy thing if you can do that, adaptation being the central theme of my presentation.
What is a GRD?
A grease removal device. It's an acronym. You know, our industry is becoming fraught. It's like a government agency becoming fraught with acronyms, and unless you were at the last two meetings, you have no idea what anyone's talking about. But and thank you, Dave. It's a grease removal device. Essentially, it's a hydromechanical grease interceptor, which first has to pass the tests for separation and retention efficiency, either to ASME A112.14.3 or PDI G101 or CSA B241, I believe, is their standard. All of them the same, 90% retention or better at peak flow, plus or minus 5%, or plus 5% minus 0. And typically they retain twice. Well, let me give you the example. 20 gallon per minute grease interceptor hydromechanical, in order to pass, would have to retain at least 40 pounds of the test grease. The advantage of a small interceptor like that is that it can be placed close to the grease source, close to the fats, oils, and greases. And the theme here is harvesting, so we want to get the grease out as quickly as possible to prevent the molecular decomposition or molecular hydrolysis, where the glycerin and the fatty acids separate. And so being as close to the contributing fixture as possible has that advantage, of course, and you have shorter grease waste piping, so you're going to have less opportunities for accumulation. For every foot of grease waste piping, you're going to have probably 2 feet of problems, because the same problem is going to recur in the same area. One of the things that I've been watching since the late 80s, and when I really got vigorous about this in the early 90s, is the disposition of fog. What do you do with this stuff, you know? I mean, you capture it in a tank, you try to store it there, and it goes anaerobic and becomes caustic and eats concrete and chemically adheres to cast iron and so on. What do you do with this material? Well, in '97, I had the opportunity to go to Isch in Frankfurt, Germany. I don't know if you've ever been there, but if you get a chance, go. It's a fascinating thing about heating and cooling and plumbing. But two of the things, other than the size of the show, the two things that I remember distinctly from that show was the Italian women demonstrating the showers. I don't remember the name of the company, but so it was probably counterproductive from that point of view, but it was memorable. And this German grease interceptor to capture Fett from Abwasser. It was, I mean, if you're into machining, your reaction to seeing this thing is visceral without getting too graphic. I mean, this thing was 3/16 polished stainless. It had sapphire sight glasses where you could see the accumulation in there, and it was about 10 feet tall, and you couldn't purchase it. You could lease it, and you had to be trained on it and so on. I mean, you wanted to just, I just wanted to go up and hug this thing. Well, anyway, I asked the fellow who was making the presentation and he got down to 5 parts per million. It was a centrifuge type device. And I asked him, what do you do with the grease once you capture it? And he said, it goes in these barrels. And they looked about 15 to 20 gallon polyethylene barrels, standard food substance barrels. And I said, but what then? And he said, well, some try to compost it, but it can't be more than 6% of the compost, or it smothers the organisms. Some put it in the primary digester at the wastewater treatment plant and convert it to biogas, to methane. But it's difficult. That was in 1997. It's difficult to get rid of. Since then, there's been quite a, partly because of the oil shortage and partly because of the vagaries of OPEC and the pricing and so on, and tremendous increasing demand for automotive fuel, much experimentation, some of it on old technology. Some of you may remember or have read about the liquefying of coal that Germany did in World War II as a fuel source. We give them credit for that. The fact is they improved the catalyst considerably, but the process was actually developed in the United States, was invented here. We didn't do anything with it because it wasn't cost effective and we had too much oil. But since then, converting woody substances, food waste, dairy wastes, slaughterhouse waste, oils and greases, polar and non-polar, to usable automotive fuel has been a hot topic. And many companies have made considerable progress, much more than I'm making on this computer trying to find my thumb drive. But the long story is that many of these processes have succeeded in making cost-effective, true automotive fuel. Gasoline, diesel, matching the ASTM requirements for those fuels. And that absolutely intrigued me. I mean, that just fascinated me. When you can take existing administrative structure, existing infrastructure, and put a waste product that you're paying. At this point, the tipping fees for FOGs are averaging in the United States about 23 to 28 cents per gallon. And as you saw yesterday, there are a lot of gallons generated. I estimated, based on the Department of Energy study, as 41,000 petrol barrels per day, and that's just interceptor grease. That doesn't include yellow grease. Yellow grease has higher resale value and broader usage, but because of its lack of contamination. But at any rate, these processes, hydrogenation, pyrolysis, thermal depolymerization, some of the more popular ones, are bringing in light sweet grade crude according to ASTM standards at about $1.20 a barrel, or excuse me, $1.20 a gallon. Well, when crude is running more than that, you now have a substance that's very attractive and a sufficient quantity, once organized, to do something with. And the advantage is that it's decentralized. Demographically, probably about the same as fuel consumption. So you can run these through a cracking plant, into a blending plant, right into the standard fuel stream through the standard pumps and tankage, just like you do gasoline and diesel made, or jet fuel. There was big news recently about the Air Force flying a jet on fuel made from seed oil grown in Montana.